Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to look at logarithms for mathematics grade 12. On that note, please don't forget to click the subscribe button and hit the notification bell so you do not miss any new videos we upload in the future. And if you have any questions or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Now back to the video. In detail, we're going to look at the definition of a logarithm, what relatives it has, and how it is connected to those relatives. Number two, we're going to look at special logarithm bases, how to spot them and how to calculate them. Number three, we're going to look at laws of logarithms and how they are related to the laws of the said relatives in number one, that we're going to also look at it in brief. Number four, we're going to look at how to calculate a logarithm, whether it is finding the base, finding the number, or simply using the calculator, and how to do that, what buttons to press, and how to calculate certain logarithms looking a certain way in the calculator. Number five, we're going to look at applications of logarithms in two subjects in particular. The first one is population growth, and the second one is finance. However, we're going to look at a whole range of applications of logarithms that we may not necessarily focus on for the purpose of demonstration in this particular video, but that you need to know of. We have a lot to cover, so let's start. First, let's start with the definition of a logarithm. This is how it is all connected. If you have a number, for example, expressed in exponential expression, 4, 2 to the power of 3, for example, is equals to 8. If that is the case, meaning that the 2 is your base, the 3 is your index or exponent, and the 8 is your number, right? Then the logarithm of that number 8 to the base 2 is equal to the exponent or index, which is equals to 3 in this case. And that is the relationship between logarithms and exponents. Now notice that also exponents are connected and related to surds. Now because of that relationship with surds, with exponents, surds are also related to logarithms as a result. So whether you are dealing with an exponential format or a surd format, you will be able to translate that into logarithmic format because of the relationship between the three. Now if those watched my videos in grade 10 and grade 12, grade 10 and grade 11, you've noticed that I've already made the relationship between all three very prominent, and I've addressed it. You can go back to those videos for clarification. Now let's look at some examples on how to write in logarithmic form. If you're given a number in exponential form, how do we do that? Let's start with the first one. You've got the number 16 equals to 2 to the power of 4, right? We've known how to do this in previous grades, so this should not be a surprise. If it is a surprise, go back to those videos I've made on exponents for grade 10 and grade 11 and familiarize yourself with that. Now, if this 16 equals to 2 to the power of 4, that means the logarithm of the number, in this case, which is 16, to the base 2 is equals to 4. And that's how you translate that into logarithmic format, right? Next, y equals to 2 to the power of x, that means therefore the logarithm of the number, which is y, to the base 2 is equals to, let me fix that, to the base 2 is equals to x. Next, 9 equals to, in bracket x minus 4 to the power of p. Now, to convert that into logarithmic format, here's your number, here's your exponent, and that is your base. Therefore, the logarithm of the number 9 to the base, in bracket x minus 4, that whole thing is a base, is equals to the exponent or index p. Number D. The logarithm of the number, in this case, which is 1 over 243, to the base 3 is equals to the exponent negative 5. And that is in a nutshell how you convert from exponential format to logarithmic format. Easy peasy so far. Let's move on. Example 2. In this example, we asked to express each of the following logarithms in words and then write in exponential form. That should not be difficult either. Now, in words, this is the logarithm of 32 to the base 2 is equal to 5. Now, let's translate that into exponential format. Therefore, the number is 32. So let's start with that. That's what I prefer. I can use another, I can start with the other one. Does not matter. You can start with whichever. This is what I prefer because it makes it easy for me to remember what to write next. 32 equals to the base 2 to the power of the index, which is 5. Number B, you've got the logarithm of 1 over 1000 equals to negative 3. Then the number, therefore the number which is 1 over 1000 is equals to, now if the base is not written, for example, in this particular case, number B, if the base is not written down, the assumption is that that base is equals to 10. So I'm going to write a small 10 there so that you keep that in mind when I translate it into exponential expression, exponential form. So that means that, therefore, that is equals to 10 to the power of negative 3. Number 3, the number is C equals to the base is D to the power of B. Now, in this case, we've got the log of 16 to the base 12. We're not given what the number is equal to. So what we do is we use exponential format and our knowledge of exponential equations up to this stage to figure out what that is supposed to be equal to. Let's put a question mark so far. Now let's work it out. So what you do is you write the number if the log of 16 to the base 1 over 2 is equals to x. Equate that to x and solve. Therefore, step number 1, change that into exponential format so you can easily solve that. Therefore, the number 16 equals to the base 1 over 2 all to the power of x. Therefore, now write 16 as a power of 2. Why? Because the 1 over 2 gives me a clue as to what base I should translate 16 into. That's what I meant to say. That is equals to, now 1 over 2 can also be written as 2 to the power of negative 1, all to the power of x. Using laws of exponents, 2 to the power of 4 equals to 2 to the power of negative x. What law of exponent did I use here? The law that says if you raise a power to another power, then you simply multiply the exponent. Now, negative 1 times x is equals to negative x. Therefore, now you've got powers of the same base equal. Therefore, the exponents are equal, meaning that therefore 4 equals to negative x. Meaning that therefore, divide both sides by negative 1 so that you can get x on its own in a positive way. That is negative 4 equals to x. Can have your x on the left-hand side if you prefer. Does not really matter which side you have it on as long as you get the answer right. Now we go back and we write the answer, which is supposed to be negative 4. So that is our answer there, negative 4. The answer is negative 4. So the log of 16 to the base half equals to negative 4. Now let's move on. On to the next one. Now let's look at the special logarithm basis. The first special logarithm base is this. It's when you've got the log of 1 to the base a, any base except for 0 is equal to 0. Let's prove that. Let's prove how that comes about. We just say, let the left-hand side, the logarithm of 1 to the base a equals to x. Let's make that x and see what we get. Now convert that into exponential format. You get 1 equals to the number equals to the base to the power of the exponent, right? Therefore, now we know that if we want to express both these two as powers of the same base, 1 can be expressed as anything to the power of 0. So because the base is a here, we express it as a to the power of 0. So that we can have a situation where we've got powers of the same base that are equal. And therefore, you just simply equate the exponent. Therefore, 0 equals to x. And that's how you prove that. Number 2, you let the log of a to the base a is equal to, let's make it y in this case. Because the rule, the special log says if the logarithm of a number to the base of the same number is equals to 1. Obviously, It does not include 0. Those are exceptions to the rule that are not part of the general equation. They're not included because there are restrictions that we do not allow because they make the whole expression undefined. Very important to remember that. Now, I did not bog us down with all those restrictions when I define the logarithm. We're going to look at those when we look at the laws so you can understand what is allowed and what is not allowed. Now, therefore, express that in exponential form. Therefore, the number a equals to the base a to the power of y. Now, a can be written as a to the power of 1. That is equals to a to the power of y. Now, we've got powers of the same base equal. Then all you do is just equate the exponent. Therefore, 1 equals to y, meaning that checks out. Yes, we've proven that the special logarithms bases are real. Now, let's move on to laws of logarithms. Now, like I said before, there's a special relationship between exponents and logarithms, and as a result, the laws are also similar. They follow a similar pattern, and as such, we need to first revisit and recap on the exponential laws so that when we look at the logarithmic laws, you understand where all that comes from. Now, here's a recap of exponential laws. When you multiply powers of the same base, you add the exponents. When you divide powers of the same base, you subtract the exponent, and when you raise a product of two or more numbers to the same power, that is the same as now that the different powers multiply together. So a times b all raised to the power of n, that is equals to a to the power of n times b to the power of n. That's what it means. Now, if you have a similar situation, not in products but a quotient, if you got a number divided by another number and all that in a ratio raised to a power of n, that is equals to the numerator to the power of n over the denominator to the same power of n. Now, if you raise a power to another power, you simply multiply the exponents, and that's what this law is about. Next, let's look at logarithmic laws. Now that we've looked at exponential laws, let's look at how that translates to logarithmic laws. Now, if you've got the log of a power, x to the power of b, in this case, to the base a, the a can be anything for 0 exactly, of course, because we have a restriction for that one. Therefore, that is equals to, all you do is you multiply the whole log by b. So you take b to the left-hand side and multiply it by the log of x to the base a. And that's how you end up with. Now, x must be greater than 0. In other words, it must be positive. X cannot be negative. That's a restriction because it makes the whole expression undefined. Now, the log of a to the power of the log of x to the base a, right, can also be written as the log of x to the base b over the log of the original base to the base b as well. In other words, that's changing the logarithm into a common base. So the base is common that you change to is b. The log of a product of two numbers is equal to the logs of the sum of the logs of the individual numbers. So the log of x times y equals to the log of x plus the log of y. Notice that I'm not even bothering with the base because it's the same thing. Now, the log of a quotient of two numbers, x over y in this case, no longer a product, is equals to the log of x to the base a minus the log of y, the denominator, to the base a. So you subtract the log of the denominator, whereas in this one, you add the logs of both the individual factors. Now, we have a special case here. Remember, I told you that exponents and their relationship to logarithm implies that surds also have a relationship with logarithms. Here is the relationship. Now, to the log of the cube, the base root of x to the base a simply equals to the log of x to the base a all over b. I can prove that. I can prove all of these laws. Now, if you want me to prove the laws, which are not part of the exam, they're not for exam purposes, just for enrichment purposes. If you'd like me to prove the laws for you, please comment down below with that request, video request, and I'll make a short video request for you, proving just the logarithmic laws. Now let's calculate some of the logarithms using the laws that we've now just learned. Simplify the following. That's example 3. The log of 10 to the power of 10 all to the base 8. That is equals to, now using this law, the first law that we've looked at, all we do is basically go b times log of x to the base 8. So that will be, using law number 1, in this case, that will be equals to simply 10 times log of 10 to the base 8. And that's it. Next, the log of the fourth root of 8 to the base 2. Now, using this law, using this special case, the log of the base root of x to the base a is simply equals to the log of x to the base a over b. So that should be equals to the log of, that should be equals to the log of 8 to the base 2 over b, which is 4 in this case. And there you go. And that should be equals to, okay, let me fix it. And that is equals to the log of 8 to the base 2 all over 4, which, if we calculate, can be calculated as, that is equals to the log of 2 to the power of 3 to the base 2 over 4. Now we've got a whole power here, the log of a power, which is equals to 3 log 2 to the base 2 or over 4. Now we know that the log of 8 to the base a, in this case 2 to the base 2, is equal to 1, according to this law. Or is it the special logarithmic basis? Yes, the log of 8 to the base a is equals to 1 according to the special basis. Now let's go back. So that is equals to, that gives us, that is equals to 3 times 1 over 4, which is equals to 3 over 4. And that's your answer there. Next, number 3, we've got the log to the base 2 of 0,125. Now what you do in this question is that you convert that decimal into a common fraction. So you go the log of 2 to the base of 1 over 125 over 1,000. 125 over 1,000. 125 over 1,000, which is how you convert that. 1, 2, 3, which is equals to the log of 2 to the base of, now if you simplify, 125 goes once into 125 and into 1,000. 1,000 divided by 125, that is equals to 8. So that is 1 over 8. That is equals to 1 over 8. Now we know that 1 over 8 can be written as 8 to the power of 1. So 1 over 8, so that is equals to, or it can be written as 2 to the power of 3. So log of 2, 1 over 2 to the power of 3 to the base 2. That is equals to log of 2 to the power of negative 3. Using the laws of exponents and taking the 2 to the power of 3 from the bottom to the top, then it changes the sign to the base 2. And that is equals to, now we've got the same situation, log of A. Now we've got log of x to the power of b. Here is the law. Let me show you the law. Here is the law we're now dealing with. The log of x to the power of b over a. I mean to the base a. That's what we're dealing with. Now let's fix that. That is equals to, so that is equals to negative 3, the log of 2 to the base 2. Log of 2 to the base 2 is equals to 1. So that is negative 3. Negative 3 times 1, which is equals to negative 3. And that is how you solve that. Next question, the log of 16 to the base 4 multiplied by the log of 81 to the base 3. All right, that is equals to the log of 16 to the base 4. Now, the bases give you a clue as to what you should convert the numbers to. That is 2 to the power of 4. No, 4 to the power of 2, sorry. 4 to the power of 2, so we can use that law with the same base n number. Now, that is log of 81 is 3 to the power of 4 to the base 4. Now, that is equals to 2 times log of 4 to the base 4 multiplied by 4 times log of 3 to the base 3. Sorry, that is to the base 3. Sorry, I made a mistake there. Okay, to the base 3, and that is equals to 2 times that law that says the log of a, that special base log of a times to the base a, so that is 2 times 1 times, so that's 2 times 1 times 4 times 1. That is equals to 2 times 4, which is equals to 8. Example 4. Convert the following. The log of 4 to the base to 2 base 8. And this one to base x. So what you do here is you use that law that can convert to a difference. So that is log of the number to the base 8 over the log of the base to the base 8 as well. And that's how you convert that. Now that is equals to the log of y, x to the base y to base x. Convert that to base x. So that is the log of the number to the base x, that is the new base, over the log of the base y to the base x. Now this one at the top is simply equals to 1 according to that special base law. That's 1 over the log of y to the base x. And that's how you convert that. Simplify the following using a change of base. Same story, that's number 3. That is equals to, okay, that will become the log of 10 over the log of 2. Notice that I did not put any base here. The base is assumed to be 10. Multiplied by, I'm going to do the same for this. Log of the number to the base log of 10. The base. Now these two now cancel each other. This one, the log, cancels with this log. And this one, the log 2, cancels with log 2. We've got 1, 1, 1, 1. So that's 1 times 1 over 1 times 1, which is equals to 1 over 1, which is equals to 1. That's what you have there. Number 4, that is equals to the log of 100 over the log of 5. 100 equals to 10. That is the 10 squared. Why 10 squared? Because when there is no base, that means the base is equals to 10, and that will help us. So that is 2 times the log of 10. Remember, that is to the base 10, so we've got a number with the same base, log of 5. So that is equals to 2 times 1 over the log of 5, which is equals to 2 over the log of 5. So for the lack of space over there. Next, example 5. If a equals to log 2 and b equals to log 3, express the following in terms of a and b. Okay, 1 equals to log 2 to the base 3 and 2 equals to log 10 over 3 to the base 2. Let's start with the first one. Log of 2 to the base 3 can also be written when you change that to a common base over log of 3. Notice that because I did not write any base, specifically that the base is 10. That is equals to, now we know from that that log of 2 is equals to a, and then the log of 3 equals to b. So therefore that is equals to a over b. And that's your answer there. Number 2, the log of 10 over 3 to the base 2. Okay, let's change that to different bases. So that is equals to the log of 10 over 3 all over the log of 2. The log of 2 is sorted so far. But remember, when you've got the log of a rational number, a quotient, that is equals to the log of the first number minus the log of the denominator over the log of 2. The log of 10, that is 10, the base is also 10, so that gives us 1. That is equals to 1 minus the log of 3 over the log of 2. But we know that the log of 3 is equals to b and the log of 2 is equals to a. So we just substitute that. So that is 1 minus b over a. And that's your answer there. Let me fix that a. Example number 6. Use a calculator to determine the value of x. Correct 2 decimal places. Check your answer by changing to exponential form. Perfect. Step number 1, change to exponential form. The log of x equals to 0.6. Notice that the base is not specified in this case. So you can assume with grace that it's equals to 10. So therefore, the number x in this case, let me fix my therefore people. The language must be right. The number x equals to 10, which is the base to the power of 0.6. Now, let's calculate that. Take out a calculator. If you're using a Casio, you go 10 to the power of, so you go x to the power of box, and you write 0.6. That will be 10 to the power of 0.6, and that gives you 3.98. So that is 3.98. So that is 3.98. 3.98 1071 blah 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 blah. And they said correct to 2 decimal, round of correct to 2 decimals. Now if you need any help with rounding off, there is a video on the nature of number, the number system, the real number system that I did, the number system that I did in the channel. Please go watch that and you will see exactly how you round off correct to any number of decimals. We are expected to round off correct to 2 decimals, so we chop off here. So that will be 3.98. So that is approximately 3.98. And that's your answer there. Number 2, step, convert that to exponential form at first. The number x equals to, now we've been given a base, so that is 5 to the power of negative 0, 1. And that is equals to, okay, so you go 5 to the power of, so x to the power of box, and that is negative 0, 1. That is equals to 0,85133, 0,85133, blah, blah, blah. That is approximately, remember, rounding off correct to 2 decimals, so that is equals to 0,85. 0,85. And that's your answer. Number 3, the log of x to the base equals to 0,25. Same story, convert to exponential format first. X equals to 2 to the power of 0,25. We should be able to do this without problems by now, and that is equals to, same story, 2 x to the power of box 0,25. That's how you punch in the calculator. That is 1,189, sorry, 1,189,207. And so on and so forth, which is approximately, remember, rounding off correct to 2 decimals, so there's no need to write it all in full. So that's 1,19. That's how you round off. 1,19. Go to that video in reference if you need help with how to round off. The log of x to the base 1 over 4 is equals to 2. Exponential form, let's convert that to exponential form. The number x equals to the base 1 over 4 to the power of 2. That is equals to, we go step number 1, you go open bracket and then the common fraction button, which is 2 boxes, one with at the top with a line dividing them and another at the bottom. And then you go 1, you press 1 for the top number, down arrow 4, right arrow, close bracket, and then x to the power of box, and in the box you write 2. That is equals to 1 over 16. That is equals to 1 over 16. Now to find that number in decimal format, you press the S to D button, and that will give you, that is equals to 0,625, and then rounding that off correct to 2 decimals is basically 0,06, and that's the answer there. Next, let's look at applications of logarithms. As promised at the beginning of the video, we're going to focus on 2 for illustration purposes in detail. However, let's look at all the many different applications of logarithms. First, seismologists use logarithms to calculate the magnitude of earthquakes. In financial institutions, they make use of logarithms to calculate the length of a loan repayments, and we're going to use that as an example to illustrate. Also, scientists use logarithms to determine the rate of radioactive decay, a very important study. Biologists use logarithms to calculate population growth rate. We're going to also look at this one in detail using an illustration. Population growth, so it's this one and the financial one. We're going to use those as examples to illustrate. Scientists use logarithms to determine pH levels. Now, those who are doing science, in chemistry, you use logarithms to calculate the pH of a base or an acid. Now, let's look at the first illustration example where we're using logarithms to determine population dynamics. The population of a city grows by 5% every 2 years. How long will it take for the city's population to triple in size? Now, let's look at the details of this particular question. The population grows by 5%. That is your rate of interest or increase every 2 years. So every 2 years, that is the how often it increases by that 5%. All right, very important. How long will it take for the city's population to triple in size? Triple in size, that is the final population. Now, the initial population we start with obviously will be P. All right, let's make that P. All right, so we're using the compound increase formula that says the final value, final amount of final population equals to the initial population P in bracket 1 plus the interest rate over 100 R, all to the power of the time period F. Now let's figure out what all these figures are in this particular question. Our R in this particular question is 5%, but every 2 years. It's compounded every 2 years. So R equals to 5% compounded every 2 years. Every 2 years. Meaning that will be equals to 5% divided by 2, which is equals to 0.05 over 2. That is R. All right. Now, next, how long will it take? We're looking for N. How long will it take? That is us looking for N, the period. For the city's population to triple in size, the final population size is 3 times the initial, 3P. It must triple. Now what we do is to find N. We go therefore N. Okay, we start with A. A equals to P in bracket 1 plus R to the power of N. All right, notice that my R is now fixed. So R is equals to 0.05 over 2. I no longer need this over 100. It's no longer necessary. Don't get confused by that. We don't have to use that if we leave our R in terms of the rate of percentage in decimals. All right, therefore, now what we do is we make N the subject of the formula. How do we do that? We first divide all sides by P. So we go A over P equals to 1 plus R to the power of N. Therefore, now, notice that you've got a number with a base to the power of an exponent. Yes, now we can change that into logarithmic format. Therefore, the log of the number, A over P in this case, to the base of 1 plus R equals to N, the exponent. So therefore, we go, sorry about that. So therefore we go, let me add another page so we can, so therefore, N equals to the logarithm of A over P to the base 1 plus R. And we know that, okay, that is equals to the log of A over P over the log of 1 plus R. That's how we calculate logarithm. To calculate, for example, the log of the number 8 to the base 2, you simply calculated the log of 8 over the log of B, 2. That's how we calculate that when you're using a calculator. So that is equals to, now let's substitute all the numbers. That is the log of, the final amount is 3P. 3P over the initial amount of P over 1 plus, and the R is 0.05 over 2. So that is equals to, now that is equals to, the p's here cancel out. So p goes into p1s and into p1s. So they cancel out. The p's cancel out. Got this p canceling out with that p. And we also have that p canceling it out with that p. So we end up with the log of 3. So that is equals to the log of 3 all over, so with the log of at the bottom, the log of 1 plus 0,05 over 2. Take out the calculator and you go the common fraction button, and then you go the log button. You'll find an open bracket, so you now just write 3, close bracket, down arrow, log, open bracket is already there, 1 plus, common fraction button again, 0,05, downward arrow, 2, right arrow, close bracket, and then that is equals to, and your answer will be 44,491, 44,491, 537, and so on and so forth. Now the question was, how long will it take for the city's population to triple in size? So that will take, therefore, okay, which is approximately, this is approximately 45 years, right? Therefore, it will take, it must be your whole number. 44 is small. 44 years will not be, the population will not be tripled in 44 years. So what you do is now you round it off correct to the nearest whole number, and that is 45. So it will take 45 years. So that is, yeah, it will take approximately 45 years. It will take 45 years for the population to triple. And that's how you calculate the population dynamics. Now, next question is, this one is a financial services type of question. Margot has 12,000 to invest and needs the money to grow to at least 30,000 to pay for her daughter's studies. If it is invested at the compound interest rate of 9% per annum, determine how long in full years, very important, her money must be invested in full years. Okay, now let's label the information. Let's annotate it. Margot has this to invest. So she starts with her initial amount, that is your P. Margot has P equals to, and needs to invest the money to grow to at least 30,000. That's a final amount, A, to pay for a doctor's studies. If it is invested in a compound interest rate of 9%, very important, compound increase, per annum, very important also. Determine how long in full years her money will be invested. How long? Okay, so the question is how long? How long is N? That is the question. You've got the initial amount, P, is 12,000 rand. That's what she invests. The final amount she aims for is 30,000 rand. That's A. 30,000 rand. That's A. The interest rate, I, or R, is equals to 9% per annum. compounded per annum, which gives us 0.09. Determine how long in full, that is n years, her money must be invested. Now we use the compound increase. Remember, I and R are exactly the same value, the same thing. So now we're looking for n. All right, let's make n the subject of a formula. Therefore, a over p, divide both sides by p, is equals to 1 plus I, all to the power of n. Therefore, now we have a number equals to a power with the base 1 plus I and the exponent a. Now let's convert that into logarithmic format. Therefore, the log of the number a over p to the base 1 plus I is equals to n, meaning that therefore n is equals to what? Let's use the next page. Therefore, n is equals to the logarithm of a over p over the log of 1 plus I. 1 plus I. Now let's substitute the values. That is equals to the log of a is 30,000. P is 12,000 all over the log of 1 plus 0.05. That is equals to the log of, now the log of 30,000. Okay, let's deal with the thousands. Thousands cancel with the thousands. Okay, the thousands cancel with the thousands. Okay, let's cancel the thousands. All right, now we're left with 12 and 30. 6 goes into 12 two times. 6 goes into 12, so 30 divided by 12. 6 goes into 12 two times and into 30. Let's see, 30 divided by 6 is equals to 5. So that becomes 5 over 2. That is the log of 5 over 2 all over the log of 1,05. If you add those two. Now let's go to the calculator. Common fraction button, then log. The open bracket is already there. Now another common fraction button. We've got 5 at the top, down arrow 2, right arrow close bracket, down arrow to go down, log. The open bracket is there. Now that's 1,05 close bracket, and that is equals to, and that gives you 18,78. That is 18,78 023 blah 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 blah, which is approximately. Remember, in full years, the question says determine how long in full years her money must be invested. Now anything less than 19 years, at 18 years, it's not yet 30,000. And then only at 19 years will it be at least more than 18,000 in full years. So that is approximately 19 years. Therefore, 19 years is the term of the investment. If she wants that to give her 30,000 after the investment of 12,000 years. about 12,000 points, I mean. Thank you very much for coming, for watching. We've come to the end of this video. Thank you. See you in the next one.